So we have got to work out which shows the melting boiling point of bromine. Bromine, it tells us, is a simple molecular structure, and that should then make you remember through your core knowledge that that means it has a low melting and boiling point. So the one that would be most appropriate in here would be this one, because we've got a low melting point, low boiling point for the halogens. It's also, bromine is a liquid at room temperature. So room temperature is often around 22. So we know that, for example, these ones here would be gases, and we know that bromine is not a gas at room temperature. Okay, in this one, why does graphene conduct electricity? Well, graphene is made from carbon, as you can see. It tells us here that it contains carbon atoms. And if we zoom in, and let's pick this carbon here, this carbon's got 1, 2, 3 bonds. And you should know that carbon wants to make 4 bonds. So what we need to say here is, for 3 marks, that carbon has 4 outer electrons. It's got 4 electrons looking to make bonds. It only forms 3 bonds, and this means it has delocalized electrons. And we always say, when we say that, which are free to move. Okay, so marks wise, 1, 2, 3. Okay, carrying on. Here we've got our ionic lattice for potassium chloride. Explain why this has a high melting point. So what we need to say in here is ionic lattices have a high melting point because they contain strong electrostatic attractions. So if you remember, that means that opposite charges attract. And because they are strong, they need a lot of energy to break them. 2 marks, 1 mark for each sentence. Okay, this next one here, this is an unusual question. Nothing like that has been asked before or since. So it is a difficult one to kind of get your head around, but I've structured some answers here to help you. This one only gives you a formula showing you the ratio of carbon to hydrogen, so you've got no idea in terms of the limitations of it, no idea how they're bonded, what the shape is. This one, you can see that you've got covalent bonds, so we've got an idea of how the bonds are being formed, but what it doesn't do is give me a shape. It's a 2D structure. And the other thing it does show you as well is these are dots and crosses showing you where the electrons are coming from. C, again, it's 2D. The sticks represent the bonds, which isn't what bonds are, but we use it as a representation. So that's the limitation, is that we've got these lines showing as the bonds, but we only have a 2D structure, not a 3D arrangement. This one now, we've got our 3D arrangement, which is good. We get to see a shape. I guess a limitation of it is that we're using sticks to represent the bonds, and they're not sticks. We know that these are shared energy levels. So we've got here, it's called a ball and stick model. It shows the shape and the bonds, but the bonds are not sticks. And this final one, here we can see the kind of relative sizes. So carbon is quite large and hydrogen is quite small. What it does, and it gives us a shape as well, so you can see we've got kind of where these atoms are in space. What it doesn't show us in there is the type of bonding is not being shown. So we can see the structure, we can see the relative sizes, but we don't get the types, the way the bond is forming. I make it 14 bullet points there. So count up how many bullet points you have got, and then use this little table here to work out the number of marks that you have been, you can award yourself for that particular question.